Hi, welcome to Unit 4, Lesson 6b. This lesson is going to be pretty similar to what we did earlier in the week, but this time we're going to be talking about exponential decay. So first off, we are going to plot the points that are given on the graph. So we know the y-intercept is 100, so our first point is going to be on that y-axis 0, 100. The second point is point B, which is at 1/4 we can see, and it tells us the y-coordinate of B is 50, so I'm going to write 50 right there. And then for C, our x-coordinate is 3/4, as we can see on the graph, and then our y-coordinate is 12.5. That's given over on the side there. Now it asks if this graph is exponential growth or decay, and we can tell it's decay because the graph is moving downwards. It's got that downward slope. And then it asks, what equation should we use? We know when we're talking about exponential functions, it's going to be this y equals a times b to the x. We've been talking about this function quite a bit, so you should feel familiar with this equation by now. And now we're going to plug in what we know about this particular function. So we have y equals a is our initial amount, which we know is 100 in this case, because that's our y-intercept. We don't know our decay factor, which is b, and we don't know our x. In order to find our b value, we're going to start by making an x and y chart, as you guys saw in the last video, and we're going to plug in the points that we have. So 0 and 100, we have 1/4 and 50. We have 2/4 or 1/2 plotted on the x-axis, but we don't know the y value. And then we have 3/4, which we know has a corresponding y value of 12.5. So eventually we want to find the decay factor for an interval of 1, but right now we're going to find it for an interval of 1/4 because we have the y value for 1/4, which is 50. You could also use 3/4 since we have the y value there, but we're just going to use 1/4 for this example. So you take the ratio of 50 over 100, which simplifies to 1/2, and this is going to be the the decay factor for every 1/4 interval. And then next up we're going to use that to find the decay factor for an interval of 1. We can use our decay factor of 1/2 to find the decay factor for any interval. The way we do that is we take 1/2 and we raise it to the power of x over the interval, right? Which in this case is 1/4. And then we just, for x, we substitute in the interval that we want to find. So in this case, it would be 1/2 raised to the power of 1 over 1/4, right? 1 being that interval that we want to find. And to simplify that out, you just flip the fraction that's in the denominator and then multiply it by the fraction in the numerator, right? So you have 1 times 4 over 1, which is 4, so we get 1/2 to the 4th power. And if you were to simplify that out, it would just be 1/2 times 1/2 times 1/2 times 1/2, and then we would get 1/16 as our decay factor for an interval of 1. So if I'm going to write that all out, we get the equation y equals 100 times 1 over 16 to the power of x. So next we're going to solve this same problem the easier way. So again, we're going to write out what we know here. So our base equation, which is y equals a times b to the x, and right now we know the initial value, or the a value, is 100, so we can put that in. And then in this example, we're actually just going to take one other point from this graph, one point that's not the y-intercept, right? So I'm going to choose the point B, which is 1/4, which is the x value, comma 50, which is the y value. And then I'm just going to plug that into the equation. So since 50 is our y value, it's going to be 50 equals 100 times b, and then 1/4 is our x value, so I'm going to plug that in for the exponent x, and then just solve this algebraically. So first we divide out that 100, right? Whatever we do to one side, we have to do to the other, and that gives us 50 over 100 on the left, which simplifies to 1/2 equals b to the power of 1/4. And to get rid of that exponent, that 1 over 4, we just multiply it by the reciprocal, right? So it's going to be, there we go, b to the 1/4. I'm going to multiply that by the exponent of 4 over 1. And whatever I do to one side, I have to do to the other. So I'm going to do that to the left side as well. 1/2 raised to the power of 4 over 1. And we know that 4 over 1 is the same thing as 4. So that's going to cancel out on the right side. And then on the left side, we have 1/2 to the power of 4, which we already solved in the last problem. We know that's 1/16 equals b. And now I'm just going to write out that equation here. So we have y equals 100 times 1/16 raised to the power of x. So that's a little bit easier way to solve that same problem. So just to check for understanding, if we know that the initial amount of an exponential function for an exponential function, what else do we need to know to find the decay factor? So we would need either, for in our first example, we know that we can use the decay factor. I'll say the growth or decay factor here, depending on if it's exponential growth or decay. And you need that growth or decay factor for a certain interval. So in our first example, the interval was 1/4, and we found out that the decay factor was 1/2 over a period of 1/4. We use that to solve the equation. The other thing we can use to find the decay factor is just 1 point, right? So in example 2, we had one other point in the graph. We used 1/4, 50. We just plugged that in to find our decay factor.